Hey, this is Mr. James. In this video, we're going to be talking about linear inequalities. But before we start, a couple of quick things to talk about when we're watching these kinds of videos. Number one, please take notes on your note sheet. You don't have to take notes of everything, but just enough notes for you to understand the topic. Number two, if I ask you to pause the video and try the next problem, please do that. Try the next problem before you unpause the video and see how I do it. Number three, if you're confused, go back, rewind, watch something again, not a problem. And number four, next class, to make sure that we watch this, we're going to have a quick video check, maybe 5 questions. That'll be easy as long as you watch the video and you understand what's going on. And if not, well then it'll definitely be a struggle. And that will count as our homework grade. To get started, let's try this warm-up. Solve each inequality and graph its solution. Here we have our inequality, right? 12 minus 7n is less than or equal to 6 minus 6n. And remember, inequalities are these, are less than or equal to, greater than or greater than or equal to. And those are inequalities. And we should know what those mean. Okay? Remember, the alligator is the bigger number. So 6 is less than 7. 6 is less than or equal to 6. Or it could be 7, right? Because 6 is less than, well, 6 is equal to 6, and 6 is equal to 7. But enough of that, let's get straight to this problem. So, to solve an inequality, you may remember that you're going to solve it just like any normal equation. Okay? So let me rewrite it over here, and we can solve it out. 12 minus 7n is less than or equal to 6 minus 6n. Let's see, I'm going to start by, I'm going to add 6n to both sides, plus 6n. So I have 12 minus 7, I've got plus 6n. I've got 12 minus 1n, there we go, that's gone. And now I'm going to, let's see, subtract 12 from both sides. Okay, so we've got negative 1n is less than or equal to negative 6. And here is the one difference between solving a normal equation and solving an inequality. You do everything the same, except when you get to this step, okay, if you divide by a negative number, you must flip the inequality the other way. Okay? That's going to be positive 6. Must flip the inequality. And we'll talk about why that happens in class next time. I'm not going to do it in here. But just remember that you need to flip if you multiply or you divide by a negative number. Okay, flip that inequality. And so we can actually graph what that looks like. If n is greater than or equal to 6, that means that I could put any number for n in here that is greater than or equal to 6. So on this number line right here, I could put in 6, so I'll give it a little dark line, or I could put anything that is greater than 6, so any of these numbers as well. So a number line, that is how we would graph it. Put a little arrow at the end to show that 6 or greater, any of those numbers will work. Now, go back to your note sheet and try solving these two problems at the top, and then try graphing what they look like down here. When you're done, unpause to see if you were right. But really, you should pause here, because I'm about to show the answers. When we look at this first problem that I've solved, the important thing to note is that I never divided or multiplied by a negative number. I did subtract 1 from both sides, but that's not going to cause me to change the direction of my inequality. So I have negative 7 is less than or equal to k. So that means that if I go down to my number line, I can go to negative 7, put a filled in dot, right, to show that I could put in 7 for k, or I could put in any numbers where k is greater than that. So, let's see, greater than negative 7 would be this way, okay, and I'll draw my arrow there to show that all the numbers greater than negative 7 would work. On the other end, here we have the second problem solved out. You notice I'm solving in much the same way. I'm getting all the p's to the same side, getting all of the numbers that don't have the variable p to the same side. But this step right here, I divide by negative 1. Okay, and you'll notice that I flip the sign from one way to the other way. Now, if your answer looks like this, okay, that's perfectly fine too. These both mean the same thing, just written in different orders. But there is a difference on how I'm going to make my one variable graph. I go down to 6, so here it is, but I'm not going to make a closed circle because this says 6 is greater than p, but not equal to. So p cannot equal 6, so I put an open circle, okay? And then, since p has to be less than 6, I'm going to draw my line this way to signify that any number that is less than p but not equal to p will work. So if you want a little reminder, you're going to draw a closed circle if you're dealing with any sort of equal to, and a open circle, okay, if you're dealing with any sort of just less than or greater than without the equal to. If you're confused by this, feel free to re-watch the problems from above to see if you can get a little bit of a handle on it. We'll practice this skill next class as well, but it's important that you at least have the foundation and these notes down. Let's go down to where it says conjunction and disjunction. This is a more advanced topic right here. Conjunction and disjunction. Conjunction is a big fancy word for and disjunction is a big fancy math word for the word or. Okay, so I'll show you what I mean. Take a look at this first problem. Okay, it says v minus 6 is less than 0, and negative 9v is less than or equal to 18. First thing we need to do is solve both of those equations. Now, it's pretty quick that this becomes v is less than 6, and it's pretty quick that this becomes v is greater than or equal to negative 2. See how I flipped that sign because I ended up having to divide by that negative 9. And when you divide by negative, you have to flip the sign. But so now how do we graph that? Well, what we're going to do is start by graphing both of them separately. I'll graph this one in red and this one in green. So v is less than 6. So I go to 6, okay, open circle, and if v is less than that, it's going in that direction. On the other hand, v is also greater than or equal to negative 2. So I go to my negative 2, I make a darkened circle, and v is greater than that. So there it is. Now a conjunction, or and, means that both of these two equations have to be satisfied, which means that my graph will only exist where both equations, or both lines are occurring. So that means I've got to erase everything out here, okay, and everything out here, okay? And actually, let me just draw a whole new graph here so you can see what it looks like. So my resulting graph for both of these will have a dark circle at negative 2, an open circle at 6, and a line in between. So the only numbers that will satisfy both the first equation and the second equation are the ones that are between negative 2 and 6, and that include negative 2 but do not include 6. And those are the only answers that will work for both the first and my second equation. Or works a little bit differently. Or is what we call a disjunction. Okay? So again, we start the same way, where we are going to just solve both of those two equations. And so if we do a quick solve here, we're going to have b is greater than or equal to, looks like 6. Or we're going to have, add 7 to both sides. Oh, easy. B is less than or equal to 0. Okay, so that's what we've got. And now again, I'm going to graph the first inequality in red and the second inequality in green. Let's see what those look like. So b is greater than or equal to 6. So I go to 6, okay, and b is greater than it, so it's going that way. And I go from the second inequality to b is 0, okay, open circle because it's not going to equal 0, but it could be less than that, so I'm going that way. And now for or, right, or is anywhere that those two lines are, right? If I say or, it means any number that satisfies that first equation or any number that satisfies that second equation. Could be one, could be the other, could be both. So my resulting graph is going to be to leave both of these. It's not the overlap, it's where both of them are. So this is my answer right here. Okay? So if you want to remember this, and a disjunction is anywhere where your two graphs overlap. Okay? Or and is a conjunction. So conjunction and anywhere they overlap. A disjunction, and or, is anywhere you have anywhere for both solutions. Okay, so you don't have to do any sort of overlap anywhere both any solution is. That's going to be in your answer. Pause the video here and try and do 5 and 6. All right, for number 5, you probably got a graph looking something like this. Right, we've got the solutions x is less than or equal to 5, or x is greater than or equal to -10. And so if you graph this, you kind of get a line going over the entire thing, right? And so what this means is that no matter what number you choose on this number line, okay, it will at least work for either this first equation or the second inequality. Okay, so for either of them. So our answer on our graph would be to draw arrows on both ends of one big line, which means that all of our answers are possible. And so if you'd like to write your answer down, you can write all real numbers. Or if you're feeling fancy, there you go. There's your answer, all real numbers. Again, if you haven't finished 6, you might want to pause the video, because in just a second, the answers are going to pop up. Alright, so here we've got our solutions for number 6, and we've got them graphed. And so, remember, this is an AND, okay? And so for an AND, you can only have a graph, you can only have solutions where both inequalities are satisfied. So that means that I've actually got to erase the portions where not both inequalities are satisfied. And so I've got to erase that, and I've got to even erase up to there. Because the number -5 doesn't actually work in this equation, because x has got to be greater than -5. So a resulting answer would be to put an open circle at -5 and an arrow going in the positive direction infinitely. At this point, it might also be useful to do a quick refresher on how to write solution sets. So remember earlier in the year when we talked about domain and range, we wrote things like this, right? Or maybe this, things like that. Okay, those were solution sets. Those were domains and ranges. And what we can do is actually give a domain for the answers to all these problems. Okay, things to remember quickly are that the soft bracket means that 0 is not included in this domain. So for something like this one variable graph from the beginning, and I'll use let's use orange for all these problems. My domain would be -7 with actually a hard bracket. I'm sorry, with a hard bracket because we include 7 up to infinity. Okay. Whereas the second one right here would be from -infinity with a soft bracket. We always use the curly brackets, or the curved brackets, the soft brackets for infinity, up to 6 with another soft bracket because we do not include 6, that kind of curved parentheses. If you can, try and write domains for each of these 3, 4, 5, and 6, and unpause the video. Pause the video now and unpause the video when you think you got them. All right, so for number 3, my domain is going to be from, -2 up until 6, okay? For number 4, this is a hard one, okay? This is a hard one to write. I'll show it to you once, and we'll talk about this later in class. My domain is going to be from -infinity up until, what is that? 0, union, sorry, I had to move everything up here for more room. So anyway, -infinity to 0, union, that's a little u, and then the other set, which will be hard bracket, what is that? 6 to infinity, okay? So if I wrote that a little cleaner, it's -infinity to 0, union, 6 to infinity, if you couldn't read that before. All right. Down here, we've got all real numbers. You could also do -infinity to infinity. And for number 6, looks like we've got a domain of 5 to infinity, not including 5. All right, I hope this has been informative for you guys, and we'll talk about inequalities and how to do them on graphs next time.